Section 4.6, the fundamental theorem of algebra. The fundamental theorem of algebra, we've touched on it briefly in the past, but in this section we're kind of formalizing it. The fundamental theorem of algebra is actually in two parts. Part number one says if f of x is a polynomial of degree n, then the equation f of x equals 0 has at least one solution in a set of complex numbers. Basically, what this is saying is that if it's a polynomial of degree whatever, when you set it equal to 0, it's going to have at least one solution. It's going to be solvable. Whether it's real or imaginary, that's not what this is saying. It's saying that there's at least one answer. Whether it's real or imaginary is to be determined by the actual problem itself, but there is going to be at least one solution. Okay, the second part of the fundamental theorem says if it's a polynomial, if f of x is a polynomial of degree n, then the equation f of x equals 0 has exactly n solutions, provided that each repeated solution is counted individually. Okay, so if we had something where, just as an example, if we had like x to the third equals 0, when we solve this, we really only have one unique individual answer. It's x equals 0. But since there are three solutions, and the equation says exactly n solutions based on degree, well, if this is degree 3, then we're going to have three solutions: x equals, and x equals. The only place this crosses the x-axis is at 0. So if we counted these three zeros individually, then we would have three solutions. But since they are the same, since they're repeated, we only really focus on one. Okay, just the one unique answer, x equals 0. Okay, so that's kind of the fundamental theorem of algebra in a nutshell. The first couple of examples are really basic. How many solutions does the equation have? I don't care what they are. All I'm asking for is a quantity. How many solutions are there? And the answer to these two questions is based on the degree, the biggest exponent. The biggest exponent here in number 1, goodness, there it is, number 1 is 3. So how many solutions does it have? It has 3 solutions. Okay, it's got 3 solutions because it is degree 3. Are they all the same? Are they all unique? I don't know. And that's not what the question is asking. It's just asking how many solutions does the equation have? And the answer there is 3. For number 2, we're not written in standard form, but it's still based on the degree. The degree in this example is 4. It's the highest exponent. So what that tells me is that I have 4 solutions. Okay, so that's a very basic example, but kind of a brief overview of how the fundamental theorem of algebra works. The highest exponent, or the degree of the polynomial, tells you how many solutions you're going to have, assuming that any repeated solutions are counted individually. Okay, so let's try using the theorem to solve an equation. Find all zeros of the function f of x equals x to the 5th plus x to the 3rd minus 2x squared minus 12x minus 8. What I would recommend you do first is graph this function in your graphing calculator. Put it in the y equals screen and just see what it looks like. And what it should look like if you graph it, if you look at a rough sketch, it should look something kind of like this. Okay, it's got that general shape. Now obviously it's a little steeper here in the middle, but general shape is that. Okay, so what this tells me is that it looks like we have a bounce. We have a bounce at -1, and it also looks like it crosses at, let's see, if I look at the calculator again, it looks like it crosses at the x value of 2. Okay, so if you remember from section 5, if the graph bounces here, that means that solution occurs an even number of times. Could be twice, could be 4 times. It's not going to be 6 times because the maximum number of solutions, or the exact number of solutions, is going to be 5. Okay, so my guess is this is either going to happen 2 times or 4 times. Okay, and I'm not sure which one. Okay, the other solution here, I'll do that in green, this x value of 2, that since it crosses the x-axis there, it's going to occur an odd number of times. So that could be 1 time, or it could be 3 times. I don't think it's going to be 5 times because remember, we do have this second solution over here that, if this occurred 5 times, then there wouldn't be any more available solutions for the -1. So I'm guessing it's either going to be 1 time or 3 times. So these two, let's see, 2 and 3 are going to be linked. 2 and 3 are going to be linked, or 1 and 4 are going to be linked. It's going to be one of those two, my guess is, but we don't know that. It could be 1 and 2. Okay, and then we might have some imaginary answers. So let's just go ahead and try figuring out what we've got here. Okay, so I'm going to use my synthetic division, and I'm going to start at -1. Or you start with an x value of -1, because I know that this is probably going to occur at least twice. I could probably use -1 twice, and that's going to get me some good answers. Okay, so I'm going to start with my synthetic division, and I'm going to have 1, and I don't have x to the 4, so that's a 0. 1x to the 3rd, -2x squared, -12x, and -8. The number I'm going to use out front, I'm going to use -1. Okay, so we'll scroll down here. Let's see, so that becomes a 1. 1 times -1 is -1. 0 plus -1 is -1 again. -1 times -1 is +1. Whoops, that's in the wrong spot. +1. 1 plus 1 is 2. 2 times -1 is -2. -2 plus -2 is -4. -4 times -1 is +4. -12 plus 4 is -8. Times -1 is +8. And we get a 0 in the end. So that's a good thing. We know that -1 is a solution one time. But since it bounces here, it's got to be an even number of times. So if it's going to work once, it's going to work a second time, or it should work a second time. So what I'm going to do is I'm going to just keep dividing here. I'm going to put -1 out front again, and I'm going to divide one more time. So 1 comes down. 1 times -1 is -1. -1 plus -1 is -2. -2 times -1 is, let's see, that's +2. 2 plus 2 is 4. 4 times -1 is -4. -4 plus -4 is -8. Times -1 is +8. -8 plus 8 is 0. So I got a 0 again. So it worked twice because it bounces. It should be an even number of times. So now what I'm going to do, I'm actually going to test it a third time, because I know if it works a third time, it's going to work a fourth time, because we got to keep that even number of solutions. Okay, so I'm going to do it one more time here. We'll put a -1 out front. We're just checking to see if -1 works again. Okay, so we'll bring down the 1 again. So 1 times -1 is -1. -2 plus -1 is -3. Times -1 is +3. 4 plus 3 is 7. Times -1 is -7. Yeah, that's not going to work. So we get -15 at the end. Okay, so we know that -1 is going to occur 2 times. Okay, it didn't work a third time, so it's not going to work a fourth time. So we know -1 occurs twice. So what I have left, so I'm going to actually get rid of this, and I'm going to get rid of this. Okay, because I don't want to use -1 again. -1 didn't work. Now, if you want to just rewrite these numbers again and start a new L, that's fine. But I'm just going to save some space and use what I've got. Okay, so now let's see. I'm going to try my x value of 2 because it crossed at 2. Lord, looks like it crosses at 2, so I'm going to try 2. Let's see if 2 gives me a 0 at the end. So we'll bring down a 1. 1 times 2 is 2. -2 plus 2 is 0. 0 times 2 is still 0. 4 plus 0 is 4. Times 2 is 8. And that worked. Got a 0 at the end. Okay? So I know for sure that it's a one-timer. I'm going to test it again, because if it works a second time, it's going to work a third time, because now we're at the cross section where it's got to be an odd number of appearances. Okay, so I'm going to bring down another L. I'm going to try 2 again. Let's see what we got. So 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. 4 plus 4 is not 0, it's 8. It's not going to work. Okay, so what do I have left? Well, I can take away that. I don't need this. And really, I don't even need this L. Okay? So what this left me with, I know that -1 worked twice, which means my factor is x plus 1, and I'm going to have that twice. X plus 1 times x plus 1. 2 worked one time, so I'm going to have x minus 2 one time. And then this right here is my remainder. Okay? So let's think about this. This was x to the 5th. When I come down, now it's x to the 4th. Come down again, it's x to the 3rd. Come down one more time, and I'm now at x squared. So I've got x squared plus 0x plus 4. Okay? And this is equal to 0. Okay? These three solutions, x plus 1, x plus 1, x minus 2, I already know what those are. We found those. We did that right here. That's what our synthetic division told us, that these three solutions, x equals -1, x equals -1, x equals 2. We have 3 of our 5 solutions. Here is where we're going to find our other 2 solutions. We need to set this factor, x squared plus 4, equal to 0 and solve. Okay, so we're going to subtract 4 from both sides. X squared equals negative 4. And then to get rid of the square, we need to square root both sides. X equals, I solve, I'm using a square root and I'm solving, so I need plus or minus, which that gives me two answers here, a positive and a negative. Let's see, the square root of 4 is 2, but it was negative 4, so then it's going to be 2i. So I have 1, goodness, struggling here. 1, 2, 3, 4, and 5. I've got two answers here, positive 2i and negative 2i. So it was a degree 5 polynomial, which means I should have 1, 2, 3, 4, and 5 solutions. Now, do we have 5 unique solutions? That was negative 1, by the way. Do we have 5 unique solutions? No, we actually have 4 unique solutions. We have 2 here, a third, and then these are the same, so 4 unique solutions. But we do have 5 solutions if we count all repeated solutions individually. All right, let's try another one here. This one, f of x equals x to the third plus 7x squared plus 16x plus 12. Probably not going to take us as long because it's only a degree 3 polynomial, which means we're not going to have as many solutions. So it probably isn't going to take us nearly as long. First step, again, plug this into your graphing calculator, see what it looks like. And when you do that, it looks a little something like this. So I'm gonna graph it. And if you're on the Zoom standard, it's going to look kind of like that. You're really not going to see much of a cross or a bounce. So what you might have to do is zoom in and zoom in for this area. And what that actually looks like when you graph it, it's going to look something like this. Okay? And we're going to have a cross right here, and we're going to have a bounce right here. That bounce looks like it occurs at negative 2, and the cross happens at negative 3. Okay? So this is going to be a cross at negative 3, cross, and this will be a bounce. So we have 3 solutions because the degree is 3. We have a cross at negative 3, which means that occurs an odd number of times, and a bounce occurring at negative 2, which means that's an even number of times. So this has to be at least twice. This has to be at least once. My guess is the only way this is going to work is if negative 2 occurs twice and negative 3 only occurs once, because that's the only way we could use an odd and an even to get to 3. Okay, so let's double check though. Let's get our solutions, our division here set up. So I'm going to have 1, and then a 7, and then 16, and then 12. I'm going to start with negative 2. We'll use the bounce first. Okay, so let's see. Put a 1 there. 1 times negative 2 is negative 2. 7 plus negative 2, or 7 minus 2 is 5. 5 times negative 2 is negative 10. 16 minus 10, or 16 plus negative 10 is 6. 6 times negative 2 is negative 12. Negative 12 plus 12, or 12 minus 12, that is a 0. That works. Okay? So, negative 2 worked once, but it's a bounce, so it's probably going to work a second time. So I'm going to bring down another L, put a negative 2 there, bring down the 1. 1 times negative 2 is negative 2. 5 plus negative 2 is 3. 3 times negative 2 is negative 6, and we get another 0. Okay? So what this leaves me with so far is that I've got x plus 2, that's what this one tells me. I've got another x plus 2, because that's what this one tells me. And then this is the remainder. This was x to the third. Now it comes down, it's x squared. When it comes down one more time, that's x. So it's really x plus 3. And if this is equal to 0, we really don't need to do anything else. We've got our 3 solutions. These are all single step equations, or single step binomials to solve. Okay, so we'll have x plus 2 equals 0. We already know what that one's going to be. It's the same thing as this one, x plus 2 equals 0. And then we're going to have x plus 3 equal to 0. Okay, so x plus 2 equals 0. That means x is equal to negative 2. Again, another one, x equals negative 2. And then x plus 3 equals 0 means x is equal to negative 3. Now, if you wanted to double check, you could do your synthetic dividing one more time. Whoops, let me make that L a little longer. And instead of using negative 2, then we'll use negative 3. So we'll bring down the 1. Let's see, 1 times negative 3 is negative 3, and we get a 0 in return. Okay? So this does in fact work. It does give you a 0 at the end. 1 solution, 2 solutions, 3 solutions. Again, not all unique, but we do have 3 solutions, and we're done. It says find the zeros of the function. We set it equal to 0. We found where it crosses and bounces on the x-axis, and we got our 3 answers. It was a degree 3 polynomial, which means 1, 2, 3 answers.